Okay, everyone, so here is the next topic. I want you to go ahead and find your colorful sheets. Remember these? Hopefully you still have them. And I'm going to have you, we're going to look at this side today, which is solubility rules, okay? Now, up here in the top right-hand corner, I wrote two things that are really important, and I would like you to write them also. And that is, if you have H plus, all right, the substance is going to be an acid. And if you have OH minus, that substance is going to be a base. Now, these two ions are on this side of the colorful sheet also. The H plus is right there at the top, okay? See the H plus one? And then at the bottom is your OH minus. It's the very first one at the bottom. It's a polyatomic ion. The first two, hydroxide and cyanide, are the only two that end in "ide," but they're at the bottom. They're both -1. Okay, so now that leads me to this part here, which I'm going to try to send you some notes, but it might be better if you follow along with me and actually make notes up, because it just might be better, because I'd be skipping around here and there. Normally when I print my notes, I would leave out stuff that I knew we weren't going to get into. But this might help you guys a little bit. So you might want to take some notes along with me. And you can just watch this a couple times if you need any extra help. All right. So this next topic is going to be about aqueous solutions, which are substances that dissolve in water. Aqua, okay? Aqueous. So if it's aqueous, that means the substance will dissolve in water. All these are going to be examples of water. Okay, so we have acids, bases, and salts. Now here's basically how they work. An acid is going to be any substance that increases the H plus concentration. So just to put it into layman's terms, if H plus is in the substance, that substance will be an acid. Okay? Now there's strong acids and weak acids. Strong acids, it's not, I don't want you to think that like a strong acid, that'll kill you and a weak one won't. It's not necessarily the case. If I had my light bulb, I would be able to show you that what it really means is the amount that it ionizes, and it can actually cause create an electric current. Okay, so for the lay person, H plus is going to mean it's going to be an acid. Now, if the substance produces OH minus, or this ion here on your colorful sheet, right, the OH minus, the hydroxide, that substance will be a base. So here's like the sum of everything up there, the summary. H plus is going to be an acid, OH minus is going to be a base. So if we're piecing together the formulas, what we did before with the positives and negatives, this side of your colorful sheet. Now you take the positive, take the negative, make them go to 0, and that's how we would do the ionic compound formula. If your positive ion is H plus, then it's going to be an acid. If the negative ion is OH minus, then it's going to be a base. Okay, now, if it has neither H plus nor OH minus, that makes the substance some type of salt. Now, there are many salts, including the salt that's in the shaker, which is sodium chloride. The positive ion is Na, the negative ion is Cl. So since it doesn't have H and it doesn't have OH, that's what makes it a salt, but it's one of many salts. Now, salts can either be soluble or insoluble, and I'm going to be teaching you about this side of this in the next video lesson. I just wanted to try to show you this now so that you can get an idea of how this works. Okay, so check out your colorful sheet. Hopefully you have it. Mine's yellow. You guys have all different colors, remember? All right, so here's how it works. We're going to piece together the formula, and we're going to decide if the substance is an acid, a base, or a salt. Now, and we're going to get the formula and see if it's an acid, base, or salt. Now, the next lesson, we're going to look at the solubility. Will it be soluble in water or will it not? Okay, so the first one is hydrogen cyanide. Okay, Now, hydrogen cyanide, if you look them up on your colorful sheet, all right, well, the hydrogen's right up here at the top, H+, and the cyanide is way down here at the bottom, Cn, and the charge is -1. Okay, so the two ions that are present are H+ and Cn-. So you got your +1 and your -1. Okay, now remember, if this by the way, this is going to end up being an acid. It's called prussic acid, but in its regular form, it's a very, very, very toxic gas. If you remember in the poison video when they were fumigating the apartment complexes where the Fremonts lived, and they exhumed the body and they looked in the lungs and they found out that there was cyanide in the lungs. You remember that it was hydrogen cyanide that they were fumigating with. All right, anyway, so since this is +1 and this is -1, +1, -1, it already adds up to 0, so we just put them together. So the formula is just going to be HCN. Okay, because you only need one of each. Now, since the positive ion is H+, that means that this is an acid. So I'm going to put an A for acid. You like that? Let me get the paper towels, which I obviously need to replace. My son's not doing his job. Okay, now let's take a look at calcium hydroxide. All right, again, now you go to your colorful sheet. All right. Calcium, by the way, is Ca. You would have your periodic tables, though, in case you didn't know that. Well, Ca is right here in the group 2. And if you find it close to my thumb there, 1, 2, third one in, it says Ca is 2+. All right, so I'm going to go write that ion down. We got Ca, and that's a 2+ charge. All right. Now, hydroxide is down here at the bottom of your colorful sheet. Okay, it's right there. See that? OH, and it's -1. So we got OH, and that's a -1 charge. Okay. I can do a brief review of all this also, but if this is +2 and this is -1, well, you got +2 and -1. That doesn't add up to 0. But if you add another OH minus, okay, now you got +2 and -1 and -1 make -2. Now we have it equaled out. Okay, so my formula here is going to be, well, I used 1 Ca, so it's going to be Ca, but I used 2 of the OH things at the bottom. And since I used 2 of them, I have to wrap it in parentheses and put a little 2 outside, kind of like that. Because remember, it says it right here. You need to use parentheses if you're using more than 1. Well, 2 is more than 1. So I wrapped the thing that I'm using in parentheses, put a little 2 out there. Okay, now since I used OH minus means it's going to be a base. So I'll just write a B in here for base. Okay? All right, now the last thing, sodium sulfate. Now look, remember, you have your periodic table. You can look up all these elements. I'm not asking you to memorize them. I didn't really make you memorize anything this year, except for maybe your name, and most of you knew that already. Okay, so sodium is Na. It's right here. Group 1, alkali metals. Can you see it? There it is, Na. All right, Na is +1. So sodium is Na, and I'm going to write plus right there. So we got 1 Na. Sulfate, remember, anything that ends in ATE is going to be at the bottom of your colorful sheet. So sulfate is right there. All right, so we got SO4, and it's a -2 charge. So there's our sulfate. SO4, and it's 2-. All right, so you got +1 and -2. That doesn't add up to 0. But if I add another sodium with it being +1, well, that one would be +1. If I add another one, that would also be +1. That would give me +2, and then that's -2 will be down to 0. So the formula for sodium sulfate is going to be Na2SO4. Okay. Na2SO4. Notice I didn't use any parentheses. The reason I didn't use any parentheses was because I was only using one of what was at the bottom of my colorful sheet, not two. All right, but look, the positive ion is an H, so it's not an acid. The negative one is an OH, so it's not a base. Now that will mean that it is going to be a salt, and I'll write an S for salt. But what we're going to figure out is that just kind of the tip of the iceberg. In the next lesson, we're going to talk about whether that salt is soluble in water and whether it is not. Now, if you remember, we made the paint in the lab. We made yellow and we made white. We used a substance called lead nitrate, which is soluble, and another substance called potassium iodide, which was also soluble. But when we poured them together, it made a yellow substance that was not soluble, and we caught it in the filter. That was a salt, but it was not a soluble one. It was an insoluble one, and we will get to that in the next lesson, okay? Hopefully you guys got that pretty well. I'll put a few to try and then maybe see if you can get them. And if you can, good. So I'll give you like maybe 5 to try. I'll post it on Google Classroom, and then we'll go over them and we'll go into the solubility stuff. All right? All right, guys. Take care. And I know you miss me because I would too if I were you. Later.